Good morning, geometry. You're going to work on these couple problems to practice. This is day 2 of lesson 4.2. So we're going to use the definitions that we learned yesterday about parallel lines to find missing angles. So it starts by saying line A is parallel to line B. So I've got line A and line B, and I'm going to add some parallel arrows to my diagram. And then I have two transversals. Remember we talked about transversals are lines that cut parallel lines. I'm going to highlight this one. I'm going to highlight my other transversal. And that's going to create some relationships here. So sometimes when you look at a big diagram like this, the spider webs, the angle madness, sometimes it's helpful to not necessarily start right with A, or just start with something that you can see right away. So I'm going to start with F, because I know F and 58 make a line together. I'm going to use that line relationship and subtract 58 from 180 to get F. So F I got is 122 degrees. When we do these, I find it helpful to write it in on the diagram. So I'll erase on this. And now I know that F is 122. I'm going to use a highlighter, and I'm going to highlight F and E are congruent because of alternate interior angles from yesterday, AIA for short. And again, I'm going to write in the degree so I know it. We talked about another angle relationship yesterday, how 58 corresponds to this angle here. And you might be saying, but there's no angle there that might help me when I get inside this triangle. I still don't have enough information. I still don't have A or D, but maybe if you start thinking about triangles from the first lesson, you'll see that we can find angle D by finding this missing angle. So I'm going to add up the two angles I know. Remember, the angles in a triangle add up to 180. So we'll get angle D is 108. Because these two are vertical to each other, so we can't forget the vertical relationship also. Now that I use corresponding angles to jump from 58 to 58, to make this jump from 58 to 58, now I'm on another triangle, and I can find angle A. So I added the two angles together. I subtracted that sum from 180 because we're in a triangle, and I got A is 14 degrees. Now, eraser. Now I'm going to make the jump. If this is 14 degrees on this transversal, B is also 14 degrees because they're corresponding angles on that transversal on this set of parallel lines. And now I can find C. We found angle D already. Now I can find angle C by using a line relationship. These two make a line. So 180 minus 14. We get 166 degrees. 166 degrees. Okay, now, if at any point it helps to just stop the video and maybe you want to try example 2 on your own, that's totally fine also. Okay, example 2, you're going to see something like this on your concept check. You can see we have a big triangle on the outside, A, B, C. And then we also have parallel lines in here. We also technically have this tinier triangle right here. I'm going to focus on these parallel lines, and I'm going to focus on this angle relationship we talked about yesterday. These two angles are same side interior. It means they add up to 180 degrees. They are not congruent. They just add up to 180 degrees. So we'll make this equation and solve for x. Again, notice how the question's not asking us to solve for x. We're solving for the measure of angle A and the measure of angle C, but I have to know x in order to get that. So pause the video for a second. Can you solve this for x? Again, pause the video for a minute and solve for x. Once I got x is 15. I'm going to go plug that in for the expression for A. 4 times 15 plus 7. So that means the measure of angle A is 67 degrees. Now we're going to go find the measure of angle C right here. Maybe you notice that these are corresponding angles. This is a transversal, and we've got a set of parallel lines. So angle C, there's no solving. We're just using corresponding angles theorem from yesterday. Corresponding angles. That's the angle relationship we're using. So this is 26 degrees. Last example I'll record here, and you can try it on your own. You can stop this video and try it, or you can watch my example. But we're using a couple different relationships here. I think it's important to note with your highlighters, we've got two sets of parallel lines. I'm going to use two different highlighters to mark that. So we have a lot of relationships going on here. The first one I'm going to solve for is x, because these two are same side interior. So x plus 106 equals 180 degrees, because those are same side interior. So I can quickly get x by subtracting that from both sides, and I get x is 74. The next relationship I'm going to look at, and again, if at any point you want to pause this video and try it on your own, you are welcome to do that. This next one, 106 and 2y, they make a line. So that's a 180 degree relationship again. But now we're finding y. So we're going to subtract 106 from both sides and then end up dividing by 2. Now, because we have we have two sets of parallel lines here, we've got two transversals, we've got some corresponding relationships here. Because of all of this, this means 106 and 4z plus 6, these are corresponding, or a cap. They're corresponding, so we're going to say 4z plus 6 equals 106, and we're going to solve for z from there. Okay, on the next page of your packet, there's a page called Angles Practice. Angles Practice. You're going to work on Angles Practice. You can do it in your group. It's problems 1 through 14. You can work on that practice. If you don't finish that in time, there's still a concept check for the last 20 minutes of class. So don't forget there's a concept check the last 20 minutes of class. Okay, let me know if you have questions. Thank you. Bye-bye.